Hello everyone, my name is Franklin. Today I'm going to talk about my project, PointNet based individual tree species classification from high density mobile and public LiDAR data. Don't be scared for this long title. This work explores how a deep learning model can perform a lightweight binary classification of tree species using of 3D geometric information from LiDAR point clouds. Okay, I will introduce my project through three key questions: why, how, and where. Let's begin. The first question is why to classify tree species. Tree species information is essential for the forest inventories, biomass and carbon estimation, and sustainable forest management. The next question is why to do a binary classification? On the one hand, this work explores how a deep learning model can effectively classify between two species using only 3D geometric data. On the other hand, Pinus sylvestris and Quercus pyrenaica are the important and significant tree species in the Iberian Peninsula, and they frequently coexist in the mixed species forest. Furthermore, broadleaf species such as Quercus pyrenaica exhibit highly variable and irregular crown structures, which pose a significant challenge to the generalization capacity of AI models training on 3D point clouds. However, there is a notable lack of systematic evaluation of point-based neural networks across the contrasting their morphologies, such as coniferous versus broadleaves. Finally, while LiDAR has become a standard tool in the forest remote sensing, most species classification approaches still rely on spectral data or handcraft features. The potential of purely geometric deep learning using only 3D shapes remain underexplored. Our objectives. The first one, evaluate the performance of algorithm 3D species developed by Professor Lucas Winnie Werther. Test the binary classification, Quercus and Pinus, input only X, Y, and Z coordinates, and assess the convergence behavior classification, stability, and geometric discriminative power. Where is located the area of study? The picture shows the study area, the site A and site B. The site A is Villaverde del Monte and site B is Terra. Both are located in the province of Soria. How is composed my data sets? The first data set, Quercus pyrenaica, were collected using a HealthLAM, a mobile LiDAR sensor. 9 forest plots were scanned in the sites that I said before. Individual tree segmentation was performed manually using Cloud Compare. The database for Pinus sylvestri is a public database for species 20K project by Polity. It has around 20,000 individual tree-point clouds by 33 species. We only use a random subset of 80 from 3,000 individual of Pinus sylvestres that we're scanning using the mobile LiDAR scanner. This workflow shows how the main dataset was structured. They combine the two databases, the Quercus and the Pinus, and you can see the both samples of the point clouds. The main dataset has key variables, for example, tree ID, species database, X, Y, and Z, hey, number of points, file name, chain veil, that is important for the training, and class, 0 for Quercus and 1 for Pinus. The next image illustrates some samples of individual tree from the main dataset. The main dataset consists of 160 individual trees, 80 for Quercus pyrenaica and 80 for Pinus sylvestris. This balanced design avoids the class imbalancing during the training. Okay, here you have some photos of the file where we survived in Soria. The 3D species algorithm based on the point net architecture is specifically designed for geometric point clouds classification. The dataset were split into 70 training and 30 for validation, with the split applied independently for species to preserve the balance. The abstraction level was setting with a number of points equal to 16,000, and additional data augmentation with a z-axis rotation with 6 rotations, each 60 degrees. For instance, 0, 60 degrees, 120 degrees, and to 300 degrees. Finally, the multi-layer perceptron was trained for 20 epochs on a binary classification where class 0 represents Quercus and class 1 the Pinus. We intentionally adopted the lightweight classification to evaluate the performing to classify these two species. Test preliminary results shows that the model converges rapidly and achieves near perfect performance. This suggests that the LiDAR derived 3D point geometric contains highly discriminative information for classifying two species. You have here some values about the results of the first train, how I said before, some settings, and the preliminary results shows overall accuracy on 91% of the 17 to 20 epochs. Additionally, the training and validation losses low and stable and no evident overfitting in this task. Additionally, we have this image to show the preliminary results, how we have 22 correct classified in the Quercus and the Pinus, and 2 errors in the both class. 3D geometrics alone could be sufficient for species discrimination. The model effectively captures a structural difference, but although these results are promising, it's important to note that it's a relatively simple binary classification task, and these results are preliminary. Performance may vary significantly in more challenging scenarios, for example, when classified between closely related species like Quercus faginea or Quercus pyrenaica. But in the summary, this first experiment demonstrates the potential of lightweight point net models for the 3 species classification using only LiDAR point clouds. The next challenge consists in validating the robustness and transferability of this approach in more complex and heterogeneous forest inventories. Okay, if you would like to learn more about this project, please scan this QR code. Thank you for all your kind attention.